I'm pleased to present you this presentation entitled Improve Basin Solar Steel by Radiative Cooling of the Glass Cover. This work is a part of a research project that aims to improve the production of basin solar steel. It is carried out at the Industrial Fluids Measurements and Application of University Jilali Bunama, Khamis Miliana. The presentation will be based on 4 points. I will begin by an introduction. Then I will present different material and methods used to carry out this work, such as the description of experimental bench and measured parameters. After that, I will present obtained results such as hourly variation of solar radiation, the daily production of solar steel, and finally, I will conclude. As you know, fresh water is essential to the health of population and participate to the socio-economic development of countries. The water resources in Algeria are low, irregular, and located in the coastal region. Algeria is characterized by an annual rainfall ranging from 200 to 400 millimeters. We can classify Algeria as a semi-arid or even arid country. The semi-arid region of Algeria have a significant sunshine duration, should contribute to their development, for example, to produce drinking water by solar distillation process. The simple solar steel can be classified according to their design. We can find the basin solar steel, the inclined solar steel, the vertical solar steel, and the spherical solar steel. Basin solar steel is one of the systems used to produce fresh water. It consists of a basin covered by a transparent surface in which there is a quantity of sea water or brackish water. The solar radiation entering the basin is absorbed by the bottom, thus heating the water that evaporates. As a result of the different temperature between hot air and inner transparent surface, the water condensates and the fresh water is collected at the bottom of the slow transparent surface. We can conclude that the difference of temperature between water and glass cover is the driving factor of solar steel's production. Also, the basin solar steel has a simple design, but it gives a low daily production. Improve the basin solar steel production can be carried out by improving the evaporation or improving the condensation. The evaporation can be improved by adding to the basin solar steel a flat plate solar collector or a parabolic solar collector. Also, we can add a reflector surface or adding a hot water tank. The condensation can be improved by cooling the walls of the solar steel, and also we can add an internal or external condenser. We can also cool the glass cover of the solar steel. The glass cover of the solar steel can be cooled by a cold water film. This method increases the production of the solar steel by 20%. Also, we can use air stream. These techniques improve the production of the solar steel by 7%. The objective of the work is to investigate experimentally the effect of cooling the glass cover of the base in solar steel by radiative effect on its production. The experimental bench consists of solar steel made of plexiglass sheet of 5 mm thickness. The absorber is an aluminum sheet covered with black paint to ensure a maximum of absorbed solar radiation. In order to minimize the heat losses, the whole is insulated with 40 mm of polystyrene foam. The basin is covered with a glass cover of 4 mm thickness. In order to cool the glass cover, the cooling system is constituted of 2 Peltier modules, 2 fans, and 2 heat exchangers. The present study was carried out at the University of Khamis Miliana with the showing characteristic. Measured parameters are: first, the solar radiation intensity, which was measured using pyranometer type CMP11. The wind velocity was measured using anemometer type Oregon, and the amount of distillate water was collected and weighed using Skoll type cairn. All parameters are recorded every 15 minutes. The cooling system was turned on 3 minutes every 30 minutes. In order to investigate the effect of radiative cooling of solar steel's glass cover on its performances, 2 cases of experiment were carried out. The first case was investigating the performances of the solar steel without cooling. The second one, the cooling system was turning on, as I said before, 3 minutes every 30 minutes. In the 2 days, the sky was practically clear. Solar radiation for the 2 days are respectively 974 and 982 watt per square meter. The wind velocity is between 0 and 2 meters per second. The figure shows the hourly variation of solar radiation intensity during the 2 experiment days. It's observed that the solar radiation during the 2 days were practically similar. The hourly variation of solar radiation has a bell form. In fact, the solar radiation increased from the sunrise up to its maximum value reached at 12 TSV, and then starts decrease until its minimum value reached at sunset. The hourly variation of production of the solar steel is presented in the shown figure. It's noted that the solar steel produces a small amount of distillate water before the sunrise, but the maximum production was observed between 12 and 18. Also, it's observed that the accumulated yield of solar steel with cooling glass cover is better than the one without cooling. The daily production of the steel without cooling is 1,217 milliliter per square meter, and when the system cooling was turning on, the production was 1,457 milliliter per square meter. We can observe that cooling the glass cover improves the solar steel production per 240 milliliters per square meter. We can conclude that solar steel production depends on several parameters such as ambient temperature, wind velocity, water depth. Also, solar steel production during the experimental days are 1,217 milliliters per square meter in the case without cooling glass cover and 1,457 milliliters per square meter with cooling the glass cover. The radiative cooling of the glass cover of the solar steels increase the production by 240 milliliters per square meter per day. It's mean for 50%. Thank you for your attention.